Hello guys, now we are gonna start by solving circuits using the symbols, the real electrical symbols, right? So for that we have to use the symbols version of this program, the Crocodile Clips. So we're gonna start by dragging one of these batteries. We're gonna change the value of the battery. We click here and we can change the value here. We're gonna type 10 volts. Now we're going to use resistors. For that we have to click on this icon, passive components. We're going to use one of these, and then we're going to use this one. We're going to place it here. We're going to change the value for 2K. 2K is 2000 ohms, right? Not just 2000 ohms. We're going to use 2000s in order to have currents in the order of the milliamps. I don't want to have very high currents, so just with milliamps will be enough. I'm gonna choose another resistor here. I'm gonna place it right here. I'm not gonna change the value. I click, I change the value here, and I type 3. Okay, so I have a 10 volts battery, and I have a 2K resistor and a 3K resistor. Okay, so now it might be a good idea to have a switch here. So let's add a switch here, and now let's close the circuit. Right, let's use the terminals to connect them, and let's close the circuit here, and let's go. So here we have a circuit. If we close it, we can see that there is some current flowing. There is 2 milliamps flowing through the circuit, right? And now we need, as always, we need to complete our table. So we have created this circuit. Well, in this circuit you cannot see the switch, but you can add it if you want to, right? And we have to measure the voltage that is being generated by the battery. I think we know this already because it's a 10 volts battery, so we can type 10 volts right away here. And now we need to measure the voltage across the 2K resistor and the voltage across the 3K resistor. Alright, so let's see how we can do that. Alright, so as always, we can measure the voltage here by placing the cursor. I have 6 volts here, and I have 10 volts here, so I'm losing 4 volts, okay? A better way to see that is using a voltmeter. I can click here, I can click on the V, that's a voltmeter, I can drag it here, okay, and now I can connect 2 terminals to both ends of the resistor. One here, one here, right? Well, so minus 4. In order to see something a positive value, we are gonna use this one, right? Okay, and now I can click this one here and the other terminal at the other end. Okay, so I have 4 volts here. So with this voltmeter, I can see that across this first resistor, okay, we have a 4 volts drop, okay, in the voltage, right? So we are losing 4 volts. Okay, we can repeat the same process for the second resistor. Okay, let's use another voltmeter here. Let's use this one. Okay, we're gonna place it here, and we can see that we are losing 6 volts. So it's very clear to see that we are producing 10 volts here, and then the first resistor uses 4 volts. Okay, we are consuming 4 volts here, and in the second resistor we are consuming 6 volts, right? So let's type it in our table. We have 4 volts here already, and we have 6 volts here already. Alright, let's check that. If you have completed the table and using the value just measured, check that the voltage across the 2K resistor, 4, plus the voltage across the 3K resistor, 6, is equal to the voltage generated by the battery. So this makes sense, okay? So 10 volts are being divided, are being consumed by this one and then this one. So when we reach the end of the circuit, we will have 0 volts again, right? Now let's focus on the current, okay? Let's see the current. Okay, if we place our volt cursor here, we see that there are 2 milliamps that are being generated by the battery, and then as this is a series circuit, we'll have 2 milliamps flowing through the first resistor, and we have 3 milliamps, well, sorry, 2 milliamps again, sorry, flowing through the second resistor. Okay, so that's as expected. As we have a series circuit, there's only one current that is flowing through the circuit. Let's type it here. So it's a series circuit. So the current that is being generated by the battery is 2 milliamps, right? Let's see what's happening here. Okay, let's change that later. 2 milliamps here, and here we have 2 milliamps, and in this one you have 2 milliamps. Right? They change this. That is really ugly. Okay. Alright. So let's say this one, and maybe 12, or well, that's too much. Let's say 11. Alright, and you can change that yourselves. Right? Let's see what we can see here. We see that the current generated by the battery is the same as the current that is going through the 2K resistor, and the same as the current that is going through the 3K resistor. That makes sense because we have the same value. In a series circuit there's only one current. Okay, and now let's check the Ohm's law. The Ohm's law says that the voltage across the 2K resistor, this voltage should be the same as the current that is flowing through the 2K resistor times the value of the resistance. Alright, so let's see if that's true. Okay, we know that the voltage here is 4 volts. The current that is flowing through this resistor is 2 milliamps. 2 milliamps is 0.002 amps. And then the resistor is 2K times 2000. Right? If we multiply these numbers, we have 4. So we are the Ohm's law is followed here. Okay, so everything is okay, and you can check this yourselves. Okay, you can use that 6 volts will be the same as multiplying 3000 times 2 milliamps, that's 0.002 amps. You can check that yourselves. Okay guys, I hope this helps. See you in class.